Welcome back. Next up, we have Pierre, who is going to introduce Substrate-connect. He'll talk about replacing RPC nodes with light clients. Pierre?
Hi, everyone. So, as Pierre just said, my name is Pierre Krieger. I'm a Rust core dev at Parachains. Going to introduce you to some new cool tech, and my talk is titled Introducing Substrate-connect, Replacing RPC nodes with light clients. If you don't understand the title, don't worry about it. You will understand in a few minutes. This talk is about explaining a problem that all major blockchain ecosystems have, the substrate-based ecosystem, but also others, Parachains, relay chain, all together. This problem is that blockchain UIs are still centralized. I'm going to explain this problem and how we are going to solve it. So, blockchain, be it Substrate, Polkadot, or any other ecosystem, is a peer-to-peer network of nodes. So you can connect to the blockchain by starting a CLI application in the background. It connects to your nodes. These nodes talk to each other, exchange messages about blocks, transactions, grant payouts, and so on and so forth. But this node is just an application that provides no visual feedback about what is happening. If you want to actually know what is happening on a blockchain, you need a user interface. I need to plug this user interface to a certain node in order to see what's happening in blockchain, but also submit transactions. A user interface is, for instance, Polkadot.js or the Fearless Wallet or MetaMask, to take the example of Ethereum, and so on and so forth. And this communication between the node and the user interface uses what is called the JSON RPC protocol. Again, this is an industry standard. It's what we do with Substrate, but all ecosystems do that right now. But there is a small problem with that. Well, not a problem with that necessarily, but one thing to be really aware of is that this user interface is very dumb. All it does is show what the node knows. The node says, hey, there's this amount of token on an account, for instance, and the user interface displays it. It doesn't try to do anything smarter than just show visually what the node knows about the chain. So if you want to have a UI plug to a blockchain, you will basically have two possibilities. The first is to have the UI connect to your own node that you have started in the background. You install it yourself on your machine, you start the node, then you start the UI, and the UI talks to your node. The second solution is to use a node that is publicly accessible, that is hosted by someone else, by a third party. And these are the two options possible right now. The first one, having your own node, is way more secure because, as I just explained, the UI just displays what the node knows about the chain. If you're using a third-party hosted node, this node might be lying to you. Or more simply, the node might be offline because they have a problem or something like that. But also, installing your own node on your machine is extremely inconvenient. You need to download it, you need to install it, you need to have it started in the background. It's very annoying for the end users who just want to use an application, whereas a third-party node is extremely convenient. And because it's extremely convenient, that's unfortunately what the vast majority of users are still doing nowadays. Again, in Substrate, but also in all other blockchain ecosystems, at least the ones I know of. And that's what I mean by blockchain UIs are still centralized, because you're actually connecting a UI to a centralized point of failure, which is a third-party accessible node. What we would like to happen is for users to switch to a third solution, which is to bundle a node directly with the UI, basically combine the UI and the node together. So you start the UI, it's very convenient, just the UI itself, nothing more, and it's secure because the node comes with it. Sorry. But UIs nowadays are web pages, they are Electron applications, basically JavaScript. So in order to bundle a node with a UI, that means that technically speaking, the node itself has to be JavaScript, which is kind of complicated from a technical point of view. But that's what we did. So Substrate-connect is a real Substrate client that runs in JavaScript. So more specifically, it is a JavaScript library. You can find it on the URL that shows on the slide, npm.js. The package is called Substrate-connect. And you initialize it. You can look on the right-hand side of the screen. You import a type named detector from this package. You use it like any other package on the NPM ecosystem. You create a detector. I will explain in a couple of minutes why it's called detector. Then you call detect.connect. Here we passed West End, but you can also pass any chain spec. It's compatible with any substrate-based chain, be it standard chains, relay chains, Polkadot-Kusama, West End, it all works. So this connect function takes 5 to 10 seconds, which is kind of long, but I'm going to explain afterwards. And after these 5 to 10 seconds, you have access to a Polkadot.js API. So what I mean by Polkadot.js API is the API type in the Polkadot.js library, which is also a JavaScript library. And then you can use it, as you can see on the example, like a regular Polkadot.js API. You call api.rpc.chain.get header, for instance, and you get the header of the best block, that kind of thing. And I want to emphasize that there's no trick. It's a node that is run in JavaScript. The node directly connects to a chain using the libp2p protocol, which is the one we use in Substrate, uses WebSockets to do that, verifies all the blocks. And as far as we know, we're the first, at least amongst the major blockchain ecosystems, to actually do that, to actually have a light client in JavaScript. I said the word light client, but I'm going to explain that later, to have a node purely in JavaScript. Its API is extremely similar. So as I just mentioned, it provides you with a Polkadot.js API. So if you've already started writing a UI that uses the Polkadot.js library, you can very easily replace the connection to RPC nodes with Substrate-connect. It's a couple of lines of changes of codes to change, and boom, you're using Substrate-connect. Extremely easy. I must mention that the API that I showed at the previous slide is still going to change a little bit, but there's so little API that it should be very easy to upgrade. It's ready right now. Just go on npm.js.com, where you don't need to go on npm.js.com. You can just use the library like any other JavaScript library. But if you don't want to do that, you're not a dev or whatever, you can go on polkadot.js.org/apps. And on the menu, on the top left-hand corner of the screen on the Polkadot.js website, you can choose the chain. And when you select Polkadot-Kusama West End, you can select Light Current Experimental. And if you choose this, it will use Substrate-connect. It doesn't work super great right now because we haven't upgraded to a lesser version. There's a couple of things to fix, but you can try it right now. However, there's a problem if we do that. Imagine a future where everything is blockchain, everything connects to a parachain. If you have 4 browser tabs open, each browser tab has a UI that uses Substrate-connect. Then you have 4 instances of Substrate-connect, which means 4 nodes, which means that each node connects individually to the various networks it wants to connect to. And that's kind of inefficient. In order to solve that, we are also developing a browser extension that is also called Substrate-connect. If you install it, then the various applications, the various browser tabs will detect that the extension is installed and will, instead of connecting directly to a blockchain, will talk to the browser extension, and the browser extension will then connect to the blockchains, which makes it possible to share resources between the various applications. So Substrate-connect is really 2 things. It's a JavaScript library, but it's also a browser extension. The JavaScript library tries to detect whether a browser extension is installed. If it is, then it makes use of it. If it is not, then it falls back to directly connecting to a blockchain. So if you just use the library, it's very transparent. You don't need to handle anything. it automatically detects whether the extension is installed at all. So a couple more details about the extension. It's providing a small UI, you know how browser extensions have small UIs. The Substrate-connect extension provides you with a UI showing the various applications that are connected to chains and which chains they are connected to. I want to emphasize again that the extension is optional. Users don't actually need to install it. If it's not installed, it's going to be less efficient. But Substrate-connect, the library, will automatically fall back to directly connecting to the chain itself. The extension considerably speeds up the chain initialization. So I mentioned earlier, it takes 5 to 10 seconds to connect to a chain. If you have the browser extension installed, these 5 to 10 seconds happen when the browser is started, and afterwards it's instantaneous because the browser extension is already connected. The extension is designed to be resilient to malicious web pages. So if you connect to a sketchy website, it cannot produce the other applications that also use the same extension. And the extension is not completely ready yet. It's not available yet on the browser stores, the Firefox, Chrome store, I don't really know how it's called. You have to download the zip right now if you want to use it, but it's going to be ready soon. Next, how things work under the hood. So Substrate-connect does not use a full node, it uses a light client. When you compile Substrate or when you download Polkadot, the Polkadot client, you have what is called a full node. Substrate-connect instead uses a light client. What's the difference? A full node fully verifies all the blocks, whereas a light client only verifies the authenticity of blocks. What that means is light clients make sure that it's actually the validator which created a block, but does not verify whether each transaction is correct. It does not verify that because verifying this would require the client to hold the entire chain of the entire state of the chain, in its memory. And the huge strength of light client is they don't need any database. So nothing stored, you just start the client. It does not load anything. It starts fresh every single time. It takes 5 to 10 seconds to initialize from scratch, downloads the latest blocks and poof, it's ready. Whereas a full node needs a couple hours, I said on the side. It's no longer true because we're implementing more faster syncing technologies recently, but it can take a few hours or more than a few hours to sync the first time. A little bit of history. So if you've been following Parity, I've actually given 2 talks about this exact same topic in the past, but this time it's ready, whereas the previous talks were just like what we're going to work on in the future. We've actually started in 2018 trying to compile Substrate itself for the browser, for WebAssembly in the browser. But mid-2019, it was working, but really not great. And Substrate was really designed with some assumptions in mind, such as having a file system or having multiple threads, which are not really completely normal assumptions that you make. But for when you run a node in the browser, when you run a node in the browser, you don't have any file system, you only have a single thread. So it was kind of wonky. So what we did instead in end of 2019 is start a brand new Substrate-compatible client named Small0. And in 2021, Small0 became ready enough to actually decide to ship it. So we started Substrate-connect on top of Small0. And now we're shipping Substrate-connect, which is ready now. So I mentioned Small0 in the previous slide. Small0 is the name of the client itself. So it's an implementation detail of Substrate-connect. If you just want to use Substrate-connect, you don't need to know that, but I'm going to explain it anyway because it's interesting. It's written completely from scratch, that does not reuse any code from Substrate. It's written in Rust. And what we do, it's not actually a client in JavaScript. It's a client in WebAssembly, and the WebAssembly is executed by the JavaScript engine. either by the browser or by Node.js. It works, both Substrate-connect works in both the browser and Node.js. However, I'm going to add this talk with the main pitfall of Substrate-connect, which is connectivity. I mentioned earlier that Substrate-connect uses WebSockets to connect to the actual chain. But we have a major issue that we're dealing with, which is that web browsers do not allow web pages to open non-secure WebSocket connections. Meaning, if you have some JavaScript or WebAssembly that wants to connect to something through a WebSocket, this something has to provide a TLS certificate. Otherwise, browsers simply refuse this, which is a huge pain for us. Browsers design this with like Web 2 technology in mind. We are doing Web 3, which is better, but we still have to deal with this legacy problem. However, web browsers do allow browser extensions to open non-secure WebSocket connections. And maybe you see where I'm going with that, which is if the Substrate-connect extension is not installed, then Substrate-connect will only be able to connect to blockchain nodes that have a TLS certificate in front. If the extension is installed, then there is no such restriction, and Substrate-connect can connect to any node on the network. And for this reason, we would really encourage end users to install extensions, to install the extension. If you're a dev building on top of Substrate-connect, we encourage you to put a little message in a corner saying, please install the extension if you haven't, because perhaps more than the resource sharing problem that I explained earlier, this is probably the main reason why you are encouraged to install the extension, to not have any restriction on who you can connect to on the peer-to-peer network. But we also have a couple of improvements to this problem in mind. So instead of using WebSockets, we are also thinking of using WebRTC. It's kind of complicated, however, from a technological point of view. So it's something that we're going to do in the future, but it's clear not ready yet. The idea, more precisely, is to bundle WebRTC clients in Substrate itself, and browsers allow web pages to establish WebRTC connections to other WebRTC clients, meaning to any node on the network, assuming Substrate clients have a WebRTC client in them. Meaning no need for TLS certificate at all, even if you don't have the extension. Another connectivity issue that you're facing right now, if you're trying Substrate-connect, is that you might have issue finding nodes that have empty slots, because the nodes on a peer-to-peer network have a limited amount of slots for other nodes. A light client such as Substrate-connect uses less resources significantly than a full node, and in this regard, we could allow more slots specifically for light clients, but this is not something implemented yet. But again, this is a future improvement. And the last idea we have in mind is to actually incentivize people to run full nodes, because light clients need to connect to full nodes in order to function. And in order to have enough slots for everyone, one idea is to actually pay people that are hosting full nodes in order for them to host the full nodes in question. And that's the end. So this was a high-level overview of Substrate-connect. If you're more interested in the technical details, we have a workshop tomorrow at 4 or 5. I don't remember exactly. I will invite you to look on the planning, and that's it for me.
All right, thanks, Pierre. That was really, really interesting, and I think this light client is going to be, a game changer that we can, decentralize quite a bit more because of it. So thanks. We have quite a few questions in the Q&A here. Someone wanted to know, what is your vision of how light this could get? Could you run it on a Raspberry Pi or a mobile phone? Is this something that would be possible in the future?
So That's an interesting question. Part of of the core technology of Substrate uses a WebAssembly virtual machine, and for technical reasons, this needs at least 64 megabytes of memory, roughly. So you cannot run it on any device with less than around 64 megabytes of memory. But a Raspberry Pi definitely, a mobile phone definitely. There shouldn't be any problem with that. We're running Substrate-connect in the browser right now, and browsers being, well, not browsers, but WebAssembly being a 32-bit technology only has 4 gigabytes of memory. So if it works in the browser, we know it's not using more than 4 gigabytes of memory. 4 gigabytes is a lot, so don't use that as the actual number, but we know it's not using huge amounts of memory.
Okay, but I can't use it on my Commodore 64.
I've measured, actually, sorry. Just to say, I measured recently, it was using roughly 100 megabytes of memory at any time.
Oh, okay. So yeah, that's very reasonable, even for pretty modern, lightweight hardware. Yeah. Okay. And someone asked, are there any security concerns with using a light client, either positive or negative, compared to just connecting to a node? And making RPC calls?
JSON to a RPC node, yes. So definitely, when you connect to an RPC node, when you connect a UI to an RPC node, the UI just displays what is in the RPC node's memory. So the RPC node could be lying to you. It could pretend that there is no money in a certain account. It could pretend you're on a completely different chain. It could show anything, basically. Whereas the light client actually verifies everything, not everything, but verifies the finality. It knows for sure that it's on the correct chain. It knows for sure that what it displays is accurate. It knows for sure that blocks have been offered by validators. And once the blocks are finalized, it knows for sure that the blocks are all 100% valid and correct.
Okay, yeah, so you don't have to trust that node since you are your own node, essentially. Yes.
Yeah, definitely.
How would you interact with different parachains? Would you use the same client? Would you have to have different clients running? How would that work?
So we've designed Substrate-connect with that in mind from day one. Substrate-connect or Small.Dot, both Substrate-connect and Small.Dot can connect to multiple chains at the same time with one single client. So there's obviously a limit to the number of chains you can connect to. You cannot connect to 200 chains because there's only so much memory, what we just explained. But you can definitely connect to, I think the most I've done is 8 chains at the same time, and it was working smoothly. Basically, you're reusing the same client for every single chain.
Oh, okay. Oh, very, very cool. Someone wanted to know, is it possible to use the light client in Rust instead of JS? Is there a Rust version of it?
So this would require a couple code modifications because the light client really assumes that it's within JavaScript. To be clear, the 95% of the code is platform agnostic, but the remaining 5% really assume that JavaScript is there, and we would need to make some modifications if you want to really use it in a standalone way, but it's definitely something feasible.
Okay. And has there been any talk about integrating the light client into already existing extensions like MetaMask or other extensions that are out there?
So you mean, for instance, for the Polkadot extension? That's something that people ask me this question a lot. That's something that we have in mind, but no plan so far. So we'll see in the future. Yeah.
Okay. Are there any people that or applications or reasons why you may suggest not to use the light client?
Good question. From an ideological perspective, I would say no. You use something decentralized all the time. Good question. I don't have anything in mind.
Okay.
Maybe there are, but not something I have in mind.
Okay. Could you compare this to a Bitcoin SPV client? Like, what are the differences between how those work and this?
I don't know what a Bitcoin SPV client is. I haven't followed anything Bitcoin for years now, technically speaking. Sorry about that.
No, it's yeah. So you talked about how having the extension bypassed that the WebSocket restriction. Is that just because extensions by default are allowed to do that, or did you have to do something to hack around that to allow it?
No. Browsers allow extensions to establish non-secure WebSocket connections. We actually did not know that, and we were looking for solutions, and we randomly tried to establish a connection in an extension, and it worked. And so we decided to go for the extension solution. There is this kind of fear that browser vendors will change their mind and not allow non-secure WebSocket connections. Hopefully not. I'm not aware of any plan about that, but hopefully not. The 100% correct solution in the long term would be WebRTC, but that's for the future.
Okay. Yeah. All right. Well, thank you, Pierre. As I said, that was this light client. I think really is a game changer. Really appreciate having you on, and we will be right back in just a few minutes with the next presentation.